Hello, we had some questions on the homework from the book in 7.5. I'm going to start off a couple problems here. I've got a couple new toys in front of me, so we're going to see what I know how to do here. So let's see here. We're going to do page 447, number 17 to start with. So the problem looks like 8 to the x squared plus 1 equals 20. Ooh, going to get used to this. 23. So what we're going to do here is we need to get the exponential part, the exponent, out from the exponent position. So we need to get it out where we can work with it. So what I'm going to do is I'm going to change this to a logarithm. So we'll have log base 8 of 23 equals x squared plus 1. And from there, it's a pretty simple equation, and we've solved these types in the past. The only problem is that this is not something we're used to, the log base 8 of 23. So we're going to change it using the change of base to log, I'm getting used to writing on this thing. Base 23, over log of 8. So we can put that in our calculator. And that'll be x squared plus 1. So basically, log of 23 over log of 8 is a number. So let's see, 23 log, using my calculator, divided by 8 log gives me about 1.508. So I can subtract 1 from both sides. And then I can take the square root. Anytime I take the square root of x squared, I get a plus or minus. So whatever this gives me should be my answer. Ooh, getting used to it. Sorry about that. There's my answer. I can put it in the calculator. So let's try another one here. There was also mentioned number 15. 15 is e to the x minus 4. And that's going to be equal to 4 raised to the 2/3 x. So this is a little different because we've got an exponential part on each side. There's a base and exponent on each side. So we can convert this to log form, but there would still be an exponent position. So there's really two ways we could do this. If you convert it to a logarithm, then do you want it to be base e or do you want it to be base 4? But a different trick we could do is we could actually take the natural, well, any log, and in this case probably the natural log would be better since we got this base e, but we can take the log of both sides. So basically I've got an equation that's balanced, so if I do the same thing to both sides, apply the same operation, then it's still balanced. Now it has new values, but those new values are on both sides. So what we can do then is we can pull the exponents out front. Here comes a kid, hold on. Sorry for the pause, I had a kid walk in. So we can pull these current exponents out front. So we'll pull the x minus 4 out front. Oops, getting used to this. I can pull the exponent over here out front as well. I'm just having fun with colors. So the reason it was beneficial to use the natural log here is that the natural log of e is just 1. You can put that in your calculator if you like. But now we're at a point where we've got x minus 4 equals 2/3 x times natural log of 4. And if you pay attention to this, 2/3 is a number, natural log of 4 is a number. So we can really just consider that a coefficient. So we could put that in the calculator and we would have, in this case, we could have x minus 4 equals some version of x, which, like I said, you can put that in the calculator. And then what we've got here is we could subtract an x from each side. So if you're going to put that in a calculator, oops, down here, you would get negative 4 equals, and you can, like I said, put this in a calculator, and then you would just divide by this part. So you could get an exact answer. Or you could put it in a calculator. So you would get x equal to this thing over here. Now that's a difficult one. There's other ways of doing it. So you could try different things. Okay. And, ooh, I don't know what I'm doing there. Let's do an undo. Okay. So let's try the last problem. And I think the last one somebody asked about was 51. So let me double check. Yeah, 51. So let's try that. 51. So, well, a lot of writing here. Log base 4 of x minus 3 plus log base 4 of x minus 2. And that gives me log base 4 of x plus 1. So the good thing on this problem is everything is the same base. Log base 4, log base 4, log base 4. That means that these three logs could be combined in some way, although I don't have to combine all three of them. But let's use a property of logs that says if we have log of x plus the log of y, that we can turn that into a single log of x times y. So let's do that, and let's just do it with the left-hand side here. So we'll have log base 4 of x minus 3 times x minus 2. And that'll be equal to the log base 4 of x plus 1. Now what's kind of neat here is that we now have not just the same bases, but on one side we have log base 4 of something equal to log base 4 of something. So in the previous example, we said that we could do the same thing to both sides and it still be equal. We can do that here. So there's really no operation for getting rid of this log, but it makes perfect sense that if you have a the same thing inside the function, that these two parts that I'm putting in green must be equal. So for the log of something to be the same as the log of something, those somethings must be the same. So we can really just kind of dismiss those logs there. They are important in the end. But here we get this equation, which if we multiply out this side, x squared will have minus 5x plus 6 equals x plus 1. So we're looking at a quadratic. So in this point, I started with a log equation. Now I'm at a quadratic equation. It does factor, it looks like x minus 6, x, excuse me, that's not right. X minus, ooh, maybe that doesn't factor. Let me see. Well, it does factor, x minus 5. Do I have something wrong here? Oh, this was plus 5. X squared minus 6x plus 5 equals 0. Yeah, I subtracted 1, so this should be 5. So I need minus 5 and minus 1. Sorry. So this gives me x equals 5 and x equals 1. Now let's kind of investigate, because one thing that should happen here is that if we go back to the original problem, email's coming in, and look at it, the argument inside the logarithm can't be negative. So we need to really just kind of check our answers like we've checked all our answers before. Lots of emails today. So if we put in 5, 5 minus 3 is positive, 5 minus 2 is positive, 5 plus 1 is positive. Okay, so 5 is good. But 1, if we said 1 minus 3, that gives us a negative number. We don't even have to check the rest of them. The negative, the positive one is bad, does not work. And very quickly, if you were to plug that 1 in, just to kind of explain why it doesn't work, if you plugged it in just to that 4 part, you would get something like this. And just say, what is that equal to? And let's call it z, for lack of better terms. So if we were trying to evaluate that, whether we did it in our calculator or in our head, if we turned that back to an exponential, basically we could use change of base on the left-hand side, but if we change it to an exponential, 4 raised to the z equals negative 2. Well, remember, no matter what this exponent is up here, it just makes the number bigger or smaller. It's either dividing by 4 a lot of times or multiplying by 4 a lot of times. It's not going to change the sign, because really the only thing that's on this left-hand side is a bunch of 4's interacting with each other. How many 4's is determined by the z. But all those 4's are positive, so you can't do anything with all those 4's to get a negative number. So that's why this negative 2 does not work. All right. If you still got questions about that, let me know. Thank you.